Hello everyone, my name is Thomas Kim. Today is February 8th, 2019. This is my fourth episode about algorithm. In this episode, we will learn how to construct subsets or subset construction or subset enumeration. About permutations, how to enumerate permutations, please watch this video. In this video, you can learn how to enumerate or construct permutations. About how to enumerate combinations or construct subsets in C++, more advanced way, please click this link. You can learn more advanced way for subset construction. This method is most efficient but quite a lot challenging if you haven't done it before. Also, we will be using Microsoft C++ compiler and GNU C++ compiler. If you haven't installed Microsoft compiler and GNU C++ compiler, please watch this video and install latest version of GNU compiler or Microsoft Visual Studio compiler. Okay, let's get started. We initially have a set S with elements 0, 1, 2, 3, and we denote this set S equal 0, 1, 2, 3, and set S's element count is denoted by S.size. In this case, S.size is 4 because set S has 4 elements. We will construct subsets of S and denote R0, R1, R2, R3. R0 has 3 elements, 0, 1, 2. R1 has 3 elements, 0, 1, 3. R2 has 3 elements, 0, 2, 3. R3 has 3 elements, 1, 2, 3. R0, R1, R2, R3 are subsets of S, and each R has 3 elements. We denote the set of subsets of S by SS, R0, R1, R2, R3. So SS equals 0, 1, 2, 0, 1, 3, 0, 2, 3, 1, 2, 3. Subset R0 has 3 elements, and R1 has 3 elements, R2 has 3 elements, and R3 has 3 elements. We call these numbers as count, and also count, also count, also count. Initially, R is empty, and S is 0, 1, 2, 3, and the count is 3, and SS is empty. This is initial configuration. Now I will state a few basic rules. Rule 1. We cannot select 5 elements out of a set with 4 elements. Here, count is 5, S.size is 4. That is, if count is greater than S.size, we cannot further proceed. We simply return. Rule 2. If S.size is equal to count, then we select all elements of S and append the elements of S to R, then move R to SS. I will explain more about Rule 2 shortly. Rule 3. Count should be always less than or equal to S.size. Otherwise, we cannot further proceed. Count is the number of selection. How can it choose more than element count of set? So count should be always less than or equal to set size. Rule 4. If count equals to 0 and R size is not 0, then we move R to SS. I think I need to give more explanation about rule 4. Each time we select an element from the set S and append the selected element to the set R, we decrement count by 1. So count equals to 0 means that we selected enough elements from the set S and appended them to the set R. So if R is not empty, then we move R to SS, the set of subsets. Now stage 1. Count is 2 because we will select one element from the set S. We copy initial stage, count is 2, then we move the first element from the set S, we delete and move to set R, like this. Then we do once again, copy and paste. We move another element from set S and move it to R, like this. Please note that this is stage 1, stage 1, stage 1, the same stage. Okay, don't get confused. Now we copy once again, paste. Now we move 2 to here. Please note that in this case it does not work. Count is 2. Count is 2 here because we decreased 1 and set S has 1 element. It violates this rule. Size should be always greater than count, greater than or equal to count. So we cannot further proceed this process. We delete, we kill. This is stage 1. Initially, this 3 means we are going to choose 3 elements, 3 more elements. And initially, the element count of subset R is empty. At the end of stage 1, subset R has 1 element and 1 element. This 2 means we are going to choose 2 more elements in next stage. Now let's move on to stage 2. Stage 2, count should be 1 more. Okay? Stage 2 means subsets R should have 2 elements and we are going to choose 1 more element in the next stage. So I copied from the previous stage. I copied and we have to change it to 1. We have to decrease 1 like this. And from this is previous stage, we copy and paste. We move 1 element from set and append it to subset R like this. Then we do once again, copy like this. Then we move second element S like this. This is second stage. We haven't finished yet. Because it initially had 3 elements, we can try 1 more. Like this. We move 3. Like this. Okay? Then, in next stage, this means we will select 1 more element in next stage. Current stage, the subsets R should have two elements. It has two elements. It has two elements. It has two elements. In next stage, we will select one more elements from this set. In next stage, we will select one more elements from this set because we can select. It still has one element. In next stage, we will select one more elements from set. But next stage set S is empty, so we kill it. Because in next stage, we cannot select one more element. So we kill it. Okay? From this case, this set, the previous stage. I copy and paste. We select one element. I remove one element and append it to subset R like this. And we do once again, copy and paste and move 3. We move 3 to subset R like this. In this case, in next stage, we have to select one more element from subset S, but we cannot because it is already empty, so we kill it. This actually amounts to this rule. Count size should be always greater than or equal to count. So in this case, set S's element count is 0, count is 1, but it violates this rule. Size is not greater than count. Okay, so we kill it. This is end of stage 2. At the end of stage 2, 2 means subsets should have two elements like this. This is end of stage 2. Also, this is end of stage 2. And 1 means we are going to select one more element from this set. This 1 means we are going to select one more element from this set. Here, we are going to select one more element from this set in next stage. So we are moving to stage 3. I copy and paste. I change it to stage 3. Now it is 0. It means we are not going to choose any more elements. Okay, now I change the last stage. This is the last stage. I modify like this. And we will open new stage here from now. I make room. We will copy this. This is previous stage. At the end of this stage 3, we have 3 elements. So from here, we move the first element like this. And we do once again. Now we move 3 to here. So this is 0, empty, 0, 0. It hold. Next stage, we are not going to select any elements. And here, I copy once again and paste. We move element 3, remove, then paste. Okay, in next stage, it still holds because subset is 0. This means 0 means we are not going to select any elements from set S. In next stage, it is empty. So here also again, I copy. This is our previous stage. I paste it. Then I copy 3, remove S3 and move to R, subset. Now this is end of our stage 3. Okay, stage 3. This is end of our stage 3. It has 3 elements and this subset has 3 elements. It has 3 elements and it has 3 elements. Now we are moving to stage 4. We copy stage 3. I copied. It is stage 4. in stage 4 we cannot decrease. Okay, we cannot decrease anymore. In this case, in stage 4, this is stage 4. Since we already have 3 elements, it amounts to this. Count is 0, S.size is not 0, not empty. Okay, let's see in stage 4. Count is 0, R is not empty. Count is 0, R is not empty. Then we move, count is 0, R is not empty. We move this set to SS, like this. Here count is 0, R is not empty. We move here to SS. Here count is 0, R is not empty. We move to SS, like this. And here, this is stage 4. Count is 0, R is not empty. We move to SS, like this. At the end of stage 4, SS becomes like this. If we union this set, we all collect together, it becomes 0, 1, 2. This is this set, and we copy this set, and we also copy this set. We also copy this set. So these are the subsets we try to construct. Now let's turn this algorithm into real C++ code. I create an empty file, and while viewing simultaneously to window, I will explain. First, we define type using set t std vector int. This is type for set using set of sets t. This is set of sets std vector set t. This is set of sets. Then we create a function called void build subsets, like this. We got set of sets like this. This is SS. This set of sets, okay, set of subsets. Actually, we need to have a set R. This R, we will call it set TR. Okay, this will have subset, and then set TS, then size T count, how many elements we are going to select. I hope you understand all the concept so far. We will call this function from another function, void test subset construction. I create another function, set of sets t ss. Initially, set of subset is empty. Set ts, we initialize 4 elements, 0, 1, 2, 3, 4 elements. Set tr, this is dummy for the time being. Then we call this function build subsets. We provide SS Please note that SS should be reference, L value reference. Then we provide R. R is dummy. Initially is empty. Initially R is empty. R is initially empty. And S is initially have 4 elements. Like this. I will make it a little bit bigger. S. Then we choose 3 elements. Now we will fill more code here. Now we apply rule 1, rule 2, rule 3, rule 4 here at the beginning. If count is greater than S.size, we are applying this rule, rule 1. We cannot further proceed, so we simply return. Okay, I will make it shorter, like this. Else if this amounts to count is 0 and R size is not 0, this part count is 0 and R size is not 0, it actually means R is not empty. Okay, R is empty. It means not empty. Then we copy. Then we move S. We move R to SS like this. SS in place back R like this. Then we return. This is rule 4. This is rule 1. Now we apply rule 2. Else if S.size is count, I will put label here. Rule 2. This is rule 4. Rule 4. This is rule 1. Rule 1. We have to move. Okay. Then this is rule 2. Then we select all elements. Then we select all elements of S and append to elements of S to R. Then we move. Then R, insert, R, end. We select all elements of S and append to elements of S to R. In this case, then we can do like this. S begin, S end. This part of code moves all elements of S, and insert to the end of R. Then we move SS in place back R. Then we move R to S. Then we return. So far, we applied rule 1 here, rule 2, rule 4. Now we need to use rule 3 here, else. In this else block, we now apply this rule. This rule actually amounts to loop like this. While some loop here, we apply rule 2 here. No, rule 3. We used rule 1, rule 2, rule 4. Now we use rule 3. Rule 3 means count should be always less than or equal to S. We use rule 3, copied here. This is rule 3. Then here we apply this stage rule. This actually amounts to loop in this while. Okay, first R in place back. We are moving last element from previous stage, first element of S to R. We append. So we can do like this. S front. Move. It means copy. First element of S to the end of R. This amounts to that. Then we have to remove first element like this. Then S, we remove first element of S like this. Erase, E-R-A-S-E, erase, S, begin. It amounts to remove first element of S. I will copy this text. Copied. Then here. Now we have done this one stage. We finished one stage. Now we are moving to next stage. How can we proceed to next stage? That's easy. We just call this function again. We are moving to next stage. Like this. Subset. The first should be SS. The second parameter should be R. See? The second parameter R. The third parameter should be S. S. Now count. Please note that we are moving to next stage. We have to -1. So from initial stage, count is 3. From stage 1, we remove the -1. We decremented. Okay? Each stage we decrement count by 1. So we have to -1 like this. Please don't forget, we in place back, we added one element to R and we called next stage and it loops back. This is loop. We have to pop up like this. R pop back. Don't forget this stage. Okay? Do not forget restoring R. But instead of doing this, I will copy here out of loop. I will make a loom. This element type is int, so I make an int default value like this. I make a loom. Then I can disable it. Instead of doing this, it's much more efficient. Then we can just copy like this. Okay? Then we don't need to pop back here. We don't need with this configuration. So I will just delete this, not to make you confusing. And I will delete this too. This is the algorithm. Now we will implement this part for auto. I would say S is subset or subset SS for auto. E means element of subset. Then we can display std cout. We are displaying element of subset. Then std cout line break, std and then another line break out of loop like this. Then we can call this function copied, paste, int main, like this. Then we have complete C++ program, like this. It's too big to display in one screen. Now let's build this code with the C++ compiler. I start Visual Studio Code, then I create a file, subset construction, CPP. I created subset construction, CPP. Then I will copy Ctrl A, Ctrl C, and paste it here. We need to include vector, We also need to include IO string, like this. Then let's compile it. I start command prompt, dir subset CPP. This is subset construction CPP, CL Microsoft compiler, EHSC subset construction CPP, FE MEXE 10. This is count. Compile once again. Okay, CLS. Okay, we have chosen 3 elements. Now let's try the element count. This is 4 elements. We select 3. Now try with 1. And we selected 1 element. I think I have to make one more change here. If count, we are not passing count as parameter. I say size t count. I will pass count like this. Count less than 1. Less than 1 means empty. Then SS is an empty set. Else less than 1 or count is greater than size, S.size. Then this is else block. Then we do subset, we build subset. I modified this part of code like this. Now let's build once again. We have to pass parameter. I will make it big. 4, 5, 6. It is total 7 element. I will pass 7. We are selecting all element, and we are selecting 3 elements out of 7 elements. So we selected 3 elements out of 7 elements. These are subsets. Now let's try with GNU compiler, G++, subset construction, CPP, or GEXE. Okay, GNU compiler works. Let me analyze this build subset function. This function basically uses loop, and inside the loop it calls build subsets recursively. So it is using loop and recursion simultaneously in this function. This method is not very efficient. I created this method long ago, over 20 years ago, while in college, but I thought this is not efficient, and I haven't actually used this algorithm. This algorithm is help you understand how to create subsets in most fundamental and simple way. But still, this algorithm is not easy. I mean, for beginning programmers, this algorithm actually is quite a lot advanced. For production level programming, instead of using this method, I created another video about subset construction in this video. In this video, I explain the theory behind the subset construction, and then I implemented in C++ code. This method is much more efficient for production level programming. Please leave your questions and comments. I will answer as soon as possible. Please subscribe to my YouTube channel. Thank you for watching.